All right, looks like everybody's back. So let's take the last 5 minutes and talk about this one here. Is there a group that feels like they've got this nailed? They want to share their screen with the group, or hold a piece of paper and talk us through how they did the calculations? If not, that's okay. Okay, all right, that's fine. So I will go ahead and walk us through that. So on this first slide here, I have the fold differences just down here in the bottom. So you can see we already calculated that 13 fold one there. VO2 per kg, it's going to be very similar, right? Because it's just the same thing, just divided by a constant and their weight. Ventilation, though, we've got a huge difference, right? 186 divided by 10 is right around 18, right? So huge fold change in ventilation, about 18-fold change, okay? Respiratory rate, that's just breaths per minute, right? So we went from about 15 to about 68. That's a 4.4. Inspiratory volume, so this is how much comes in with each breath, right? Went from about 0.6, about 2/3 of a liter, to about 2.75 liters. That's a 4-fold change, okay? And just think about ventilation like we do cardiac output, but with the lungs. Ventilation is going to equal respiratory rate times tidal volume, right, or inspiratory volume, okay? Just like cardiac output is heart rate times stroke volume, okay? So it's how many breaths per minute or beats per minute multiplied by how much per breath or per beat, okay? So we got that. Heart rate, we got about a 3-fold change in heart rate. End diastolic volume goes up some, and systolic volume none at all. Arterial oxygen content none, and venous actually goes down, right? Okay, so let's look at that. So our inspiratory capacity, so we got these here. The ones that we had to calculate were cardiac output, right? So what did we have? Well, let's start with stroke volume. What did we have for stroke volume? We had to do end diastolic volume minus end systolic volume, right? And I don't have this off the top of my head, so somebody needs to help me here. What's our stroke volume here?
For resting, it was 80, and for max, it was 160.
Thank you. So 160, divide that by 80. So that's a simple 2-fold difference, right? Thank you, Maddie. Okay, what about cardiac output? We got for resting, we've got stroke volume times heart rate. So we had that 80 times our heart rate. What was our resting heart rate here? It was 60. 80 times 60. Okay, and then our maximal one was 160 times our heart rate at max, which was 200. Okay, so what was our, and you can convert that, it should be in liters per minute. Okay, but what are our numbers there? What's the resting cardiac output? Somebody help me out.
4,800.
Okay, so we'll call that 4.8 liters per minute. Okay, and then what about maximal?
32,000.
Okay, so 32 liters per minute. So those were both in mils per minute, right? With both the ones that the students told me. So we just convert that by moving the decimal place 3 to the left. So we go from 4.8 to 32. And what fold difference was that one, you guys? Somebody tell me that. 32 divided by
6.66.
6.66. Thank you. Okay, so we got that. Yeah. So bottom line here is I can show you this one. Let me just get this out of the way here. Yeah. So I can show you what the calculations there. But we've got so cardiac output right there, about a 5-fold increase. AVO2 difference only 2-fold. But still, this ventilation is the big one, right? So C is definitely the correct answer here. And it's pretty much always going to be the highest one. And that kind of just is helping to prove this point that ventilation and the lungs in general are way ahead of everything else, right? And those are not typically the limiting factor when we talk about VO2 max, okay? But which one would be one of the lowest ones here? We got 2, right? We got AVO2 difference of 2-fold, and we got stroke volume of 2-fold, okay? So typically our number one limiter of VO2 max is stroke volume, okay? And so it just works out this way that when you do these calculations, you'll find that stroke volume is typically the smallest increase from rest to max. ventilation is the greatest, and ventilation is almost never our limiter. Stroke volume is typically the limiter of VO2 max. Okay, so if you want to have a high VO2 max, you got to have a big, powerful heart with produce a lot of stroke volume. Okay, so we'll leave it there for that one. Any questions about that? Okay, so what I'll do is I will send out a kind of an announcement just assigning you each team a slide or two that you're going to present on over the next couple of days. Okay, I don't want to finish this class without just acknowledging the